There are instances when you're given a zero via a graph, and then there's other instances where they give you the zeros in the problem, but then you have to find all of the other ones. So for instance, if I'm looking at this graph, I can clearly see because I'm counting from 0 to 5 on the major lines. If I count in between, I see it's counting by ones. So in seeing that, I noticed that there is actually a point on my x-axis for 2. That's important to note because when I am trying to find my roots, my starting point is going to be synthetic division. So this 0 on 2 is what I want to start with. The other ones look like they're on like -3 and +3, but however, they aren't. They're very close, but they're not exactly on them. Now, my coefficients and constants simply mean I would drop all the variables and I would write the numbers that are left. So I'm left with a 1, -2, -8, and +16. I want to make sure that this polynomial is in standard form, because if it's not, then I would need to use a 0 placement holder. What's underneath the line, I multiply times the divisor, and what's above, I add down. So the first step is to take the first coefficient and bring that down, and then start the process. 1 times 2, -2 plus 2, 0 times 2, -8 plus 0, and then -8 times 2. If I'm doing it correctly, then the signs will be different, but the numbers will be the same, which will result in the remainder of 0. What I'm looking for is I'm trying to get it down to x squared. So that's where I'm at right now, x squared plus 0x minus 8. Well, that might be confusing to look at, so let's rewrite this as x squared. We don't need the plus 0x because it's no longer there. The x values are gone. And then minus 8 equals 0. What I would suggest is that you go ahead and use your completing the square method, which means you're going to do the inverse, which is to add 8 on both sides. And now you end up with x squared is equal to +8. If you take the square root of both sides, make sure you have a plus or minus here. The purpose of doing that, you're going to get rid of that square there. But if you take the square root of both sides, you can end up with 2 answers at one time. So you have a plus or minus. And if I'm factoring this, not factoring, simplifying, 4 times 2, but since square root of 8 is under the radical, I do always do that as well with my factor so that I can see square root of 4 is a 2 that's no longer under the radical, but this radical I can't do anything with. So my answer is 2 radical 2. Well, I see that this is 2 answers. I need 3. So I have to remember that my synthetic division started with one of my roots. So my final answer will be x is equal to the set of, and I will go ahead and take that 2 that came from my graph and these 2 answers that I just solved for, plus 2 radical 2 and -2 radical 2. And again, I was looking for 3 answers, and those are my 3 answers. That's when I'm giving a point on a graph, and I have to find the other zeros. There are cases when they tell you in the problem, okay, so given 0 roots of x equals -3, -2, 5, write the standard form of a polynomial. Well, in order to do that, you would want to put the zeros in factored form. So I have 1, 2, 3. So I'm going to create 3 binomials or factors, because that's what these are, factors. And then I'm going to take this x and I'm going to put it in for the first term for each one of those binomials. And now I'm simply going to do the inverse or flip the sign. So instead of -3, it's now +3. Instead of 2, it's -2. Instead of 5, it's -5. Now, in order to write the standard form of a polynomial, I'm going to have to multiply this information out. I personally like the box method. You can use another method if you feel more comfortable. So I'm going to start with 2 of my factors. And I'm going to write x plus 3 on top. x minus 2 along the side. It does not matter if you wanted to write x plus 3 and then x minus 2 on top, that's fine. Now you multiply x times x squared, x times 3, 3x, negative 2 times x, negative 2x, negative 2 times 3, negative 6. At this point, I see diagonally I can combine those two terms. What I'm going to do now is create another box, this time with the answer from this first box. My first box is x squared, the entire first box, that's what I meant. So this first box or cell is x squared. The second one I can combine with a third, so 3x minus 2x is positive x. And then I'm left with the negative 6. So that's my answer for this portion. I now have to take that answer and multiply it times x minus 5. So again, I'm going to create another box. I already have my columns on the top, and x minus 5 will go along the side. I do the same thing. X times x squared is x cubed, x times x squared, x times negative 6x. Again, I notice my exponents are going down 3, 2, 1, and then I take this last row and multiply times everything on top. Negative 5 times x squared, negative 5x squared, negative 5 times x, negative 5x, negative 5 times negative 6, positive 30. And I am looking again to see if there's anything I can combine, and diagonally I can combine my x squared and I can combine my x's. So now my final answer is going to be y is equal to, I take my first box, which is x cubed, go to the second box and I recognize I can combine it. So that's going to be negative 4x squared. And then I go to my third box and I can combine it as well, negative 11x, because I'm adding them. And then finally, I have my last box, which is plus 30. So this is the actual answer, for this, what they wanted, write the standard form of a polynomial. That's what it would look like. Okay. So there's also, sometimes you might have something that looks like this. If polynomial has zeros at 2, radical 5, and 3i, what other zeros have to be included? Well, you have to understand there's something called conjugate pairs. That simply means, like for the radicals and the imaginary numbers, I have to have both signs, positive and negative. I do nothing with my real numbers. I just leave my real numbers as they are shown. So for the first part, the zeros that are missing, if I have 2, I don't have to do anything. I have a radical 5, so the negative radical 5 is missing. I have a 3i, that means the conjugate pair is negative 3i. So the second part of the question is asking, well, what is the degree based on the zeros? Well, there's 1, 2, 3 zeros, and I just added 4, 5. So my degree would be 5. What does that mean? That means my x would be raised to the 5th power, given those zeros. Okay? And then I have one here that says, given that x plus the quantity of x plus 1 is a factor, find all roots for y equals x to the 4th minus 2x cubed plus 6x squared minus 18x minus 27. So again, the first step is to actually, you want to do synthetic division. So you need a divisor. This is given in factored form. So your divisor will be the opposite sign of what's shown here. Or if you need to set it equal to 0 and solve for x, do so. So this one's easy. If this is positive 1, my divisor is negative 1. I'm saying divisor because that's what it is, but guess what? It's also a root. So keep that in mind. Okay, so now I'm going to drop all of these variables and I'm just going to bring down the numbers, which are my coefficients and my constant. I have 1, negative 2, 6, negative 18, and negative 27. Again, synthetic division means you bring down that first coefficient Everything below the line is multiplied. Everything above is added up and down. So that's what I end up with here. And if I'm doing it correctly, it will be the opposite sign, but the same number, which results in 0. So I know that this is one of my roots. I knew that going in, but just that verifies it. And now I look at my highest exponent that I started with, which was x to the 4th, and my new variable will start 1 degree down. It would be easier to go ahead and do another synthetic division. However, I don't have a divisor. So I could try my rational root theorem and try to determine, well, what are all the factors of 27 and just guess and check. Or it would make more sense for me to just go ahead and try to factor by grouping. So I'm going to take the first 2 terms and I'm going to group them, and the second 2 terms and I'm going to group them. And the purpose of doing that is so that I can factor out the greatest common factor. So between those 2, I can factor out an x squared. And when I divide each term by the x squared, I'm left with x, and I'm left with -3. I do the same for the second set of parentheses. I can divide out a +9. And again, if I divide 9x by 9, the 9's go away, I'm left with x. -27 divided by 9, I'm left with -3. I know I'm on the right track if my greatest common factor between both terms, and a term is everything before and after an operation, if everything, so in this case, x minus 3 is my greatest common factor. Okay, so I'm going to factor that out, x minus 3. So when I factor that out, I'm left with x squared plus 9. So I take that information and I put it in its own set of parentheses. Now I have to take each one of these and use the zero product property rule, and I'm going to set it equal to, what will set it equal to 0? What will make this variable equal 0? What would make this true? That's what I'm trying to say. X minus 3 equals 0. What would I have to put in the place of x to make that true? It's simply 3. So I can go ahead and say x is equal to 3 here. Now here, I have to do a little bit more. X squared plus 9 equals 0. Well, I can take that 9 and move it to the other side, change the sign, of course, and I end up with taking the square root of both sides, and I'm left with x is equal to plus or minus 3i. Where did I get that from? Because the square root of 9 is 3, and anytime you see a negative under a radical, you will automatically bring an I out. So I have 1, 2, 3 answers at the bottom. However, I'm looking for 4 answers. So what I have to remember is that my first 0 or root came from my synthetic division. So this is actually one of my answers as well. So -1, +3, +3i, and -3i, for a total of 4 roots, given that x plus 1 was a factor. So make sure you understand that when you're trying to find zeros, your problems can come in different forms. Okay? Have a good day, you guys.